Hey everybody, my name is Noel and thanks for joining me again. Another edition of Synergetics and Nuclear Structure. If you haven't seen my other videos, feel free to watch those. Give you some background information about what I'm going to talk about today. Today I'm going to give us what I hope is an idea of why the strong nuclear force is approximately 10 to the 39 times as strong as gravity, in accord with Newton's theories. So I'm going to go over a little bit of information first. I've got two boards I'm going to go over. I wanted to kind of mention that something Korzybski said. Korzybski's a semanticist. He says the map is not the territory. And so what we find when we use maps and models is that you go out into the world and you have a map and says there's a river here, and that's cool, but it doesn't tell you whether the river's going to be full or flowing, or whether there's rocks here, or the individual aspects of the territory. So it's just interesting. Korzybski's an interested man. So the map is not the territory. What's cool about that is that, and interesting, is that the way right now that nuclear explorers are creating a map is by taking the territory, which is the nucleus of the atom, and destructuring it or blowing it up. So the nuclear explorer, whose favorite tool is the atom smasher, is smashing these atoms up basically, and then we're creating maps and models from the information that we have. So what happened then, as I maybe mentioned or inferred before, is that Bucky says that he found nature's coordinate system, which is the isotropic vector matrix. And so I decided that I would use this metric, or system of measurement, which is a 6-axis metric of the isotropic vector matrix, to see whether or not I could use the data points from nuclear physics upon the map or model of the isotropic vector matrix to see if these number patterns fit in a rational whole unit way. And as you've been watching over these last videos, I've been demonstrating how I've found just that. So now what we have to ask ourselves then is, if this model is a correct representation of an expanding field dynamic, which is symmetrical, and whether these numbers are actually giving us identifications between the parameters of the nucleus of the atom. I'm going to go over the number scales again then just real quickly. We have the alpha scale, we have the Penn scale, and we have the quanta scale, and there's certain number points associated with those. You have to watch my other videos as I explain then how we deduce these two numbers. 17 and 23 interrelate with the number 137. These are prime numbers and how prime numbers pattern and interrevolve around each other. Double check and make sure that thing's running properly. So 17 and the 23 revolve around the 137 in such a way that they meet up at this first 0 point, 9,384. And the numbers which are outside of this field, which I call a wave embracement field, is 274. Notice how many numbers then these different numbers on my scale, 0 points and wave embracement fields, translate to as far as vector totals within structure, within the self-stabilizing intertriangulated matrix of the isotropic vector matrix, which uses the octahedral tetrahedral trussing system in order to structure and hold in place the vectors. 938.4 is the mega electron voltage for the rest energy of the proton. That can be transformed into Planck's constant times 10 to the 34 times 2 to the third power plus the fine structure constant times 10 to the fifth times 12, which is the total number of vertexes in the vector equilibrium. And then this number here translates into 782, which is the mega electron voltage of the free neutron's binding energy, times 10 to the third, times 12. So we have not just one number which shows up, which would have made me say, oh, that's kind of cool, and passed on. But the number patterns became so conclusive and evidentiary that I had to continue following them. And so this is where it's leading us again, folks. The wave embracement field is 137 times 2. Now each of these 0 points in relationship to how these numbers are patterning around each other continue to double then ad infinitum. So the first 0 point is 9384, the second one's 9384 times 2, then times 4, then times 8, then times 16, etc. The same for all of the 0 points in the wave embracement fields, which I'm speaking about. So then I find that 17 and 23 also revolve around 919 and create vector structures within the tetrahedron and the polyhedrons, which identify numbers, these numbers, as the total number of vector points. Keep in mind that that's what's happening here. So the tetrahedron, which has 137 spheres to the edge length, which is called the 136 frequency tetrahedron, has exactly 9,384 times 274 vectors. And what are vectors? We're going to remember that in accord with synergetics, vectors represent energy forces of given magnitude operating at given angles upon given entities at given loci. And remember that vectors never come singly. They only occur as a full family of forces interacting in any physical circumstance. So those are Bucky's words, close approximation of what he says. So look at the numbers then once again. 17 and 23 revolve around 919, and we get this data point where they meet up. And this is the field around them, 1838. Now this data point, 422,280, translates into 9384 times 45. Remember, we're showing identities, numerical identities in this map or model of structure, times 45, or 1/8 of a spin. This equals or translates into 782, which is again the MeV for the free neutrons binding energy, times 10 to the third, times 540. 540 is the amount of volume within the vector equilibrium of the third frequency. It's also 1.5 spin. So this number translates into this number, which translates into, or transforms. See, these are equations where things are equal to each other. And these are based on the formulas which I discovered for how many vectors are in the different polyhedrons within the isotopic vector matrix as it expands omnidirectionally. So this number, 782 times 540, then translates into 1836 times 92 times 2.5. 1836 is the mass ratio of the proton compared to the electron. 92 is the total number of electrons or protons in uranium. 92 naturally regenerative elements. 2.5 is the amount of volume in the pre-time, pre-size vector equilibrium, also the vector equilibrium who has a half of a vector length compared to a full vector length. 1838 times 2 translates as 137 plus 6.625. Oh, I didn't get to the next one. Oh my gosh, I'm so sorry. So that Penn scale 0 point still translates one more time into 6.625, which is the Planck's constant times 10 to the 34 times 2 to the third plus the fine structure constant times 10 to the fifth. Multiply that by 540. So you've got 1, 2, 3, 4 different nuclear number equations showing for the total number of vectors which are in this Penn scale 0 points and the embracement field, which are creating structure. The embracement field then translates as 137 plus 6.625 times 2 to the third plus 729. The fine structure constant's inverse plus Planck's constant times 10 to the 34 times 2 to the third plus the fine structure constant times 10 to the fifth times 2. That's super cool. And then this is equal to the inverse of the fine structure constant plus the mega electron voltage of the free neutrons binding energy times 10 to the third times 2. And then remember that the tetrahedron with 919 spheres to its edge length, called the 918 frequency tetrahedron, has exactly this many vectors times this many vectors, or because we're changing it around, has this many vectors times this many vectors, or this many vectors times this many vectors, or this many vectors times this many vectors. So we're getting Planck's constant, the fine structure constant, the mega electron voltage of the proton, all ratioing in as a total number of vectors and transforming into different nuclear numbers. That's real powerful because remember that the polyhedrons transform into one another simply by 90-degree shift phasing of the vectors in some instances. For instance, the cube transforming into the vector equilibrium, and both of these transforming into the rhombic dodecahedron simply by either 45-degree spin shift or 90-degree spin shifting of those 24 external vectors. We'll move on to the quanta point then. The quanta scale, once again, 0 points, relate how 613, a prime number, and 919, prime number, revolve and interrelate with the prime number 3677. The quanta scale's first 0 point is 6760164, and this continues to double ad infinitum as this one does, which is why these ratios here continue to double and hold their same ratio. This translates into Planck's constant times 10 to the 40 plus the inverse of the fine structure constant times 10 to the third minus the mass of the proton. And this translates into the mass of the neutron times 2 to the second power minus the mass of the electron divided by 2. On our wave embracement field for the quanta scale, we have 7354, which is equal to Planck's constant times 10 to the 34, times 10 to the 37, plus the fine structure constant times 10 to the 5th, which is equal to the mass of the neutron times 4. Once again, the total number of vectors in the tetrahedron, which has 3,677 spheres to its edge length, or 3,676 frequency, is equal to this number times this number. That's how many total vectors are interconnecting the total number of closest packed unit radius spheres in this polyhedron, that one, in these tetrahedrons, right? So you've got this number times this number, or this number times this number, or this number times this number, or this number times this number as the total number of vectors. So remember what's happening here. Now we'll take our favorite tool, right, nuclear physicists, we'll take these polyhedrons and we'll throw them into our Large Hadron Colliders and we'll smash them up. Look at the numbers we got. We got these total numbers, and then they break up into these numbers that you guys are having your numbers break up into. Take one whole unit, break it up, this is what I get. One whole unit, break it up, this is what I get. One whole unit, break it up, this is what I get. I want to remind us some interesting aspects of the quanta scale and the Penn scale's relationship. Remember, these numbers continue to double ad infinitum. Once this one's doubled to its 5th 0 point, and it's at 6,756,480, it starts ratioing to the quanta scale 0 point, and these ratios continue ad infinitum. This one doubles, and this one doubles, this one doubles, and this one doubles, and they continue to double. So this ratio is always the same. You divide this by this, quanta scale's first 0 point divided by the Penn scale's 5th 0 point, and equals 1.00054. That's the electron's atomic mass unit. If you take 938.4 and you multiply it by 0.000545, which is what this ratio is, you get 0.511, the megaelectron voltages of the electron. If you take this first 0 point of the quanta scale, and all continuing ones, as they double, and you continue to double this when you're doing it, but anyways, here's our first 0 point. You take 1 divided by the second root of 6,760,164 divided by 360, and we have the fine structure constant out to 6 places, 0.007297. When this number doubles and the 360 degrees goes to 720 degrees, this number ratio stays constant. So now what we're asking then is, if we've deduced that there's a coordinate system that nature uses in order to self-stabilize its intertriangulated energy patterns into structure, and we'll remind ourselves something else Korzybski said. He said, words cause conditioned associations and mechanical reactions that keep our minds locked into specific reality tunnels. And right now we use words such as cubing and squaring to imply third powering and second powering, and we're trying to find the building block to the universe, and that's implying that we're still looking for cubes to structure stuff, and we're still ratioing things in accord with the edge length of the cube, which we showed is creating an irrational volumetric involvement domain between the volumes of the other polyhedrons as they ratio this way. So if this map and the charts I've drawn up are reflecting an accurate numerical model of the territory within the nucleus of the atom, we may be able to deduce through inference why the strong nuclear force is approximately 10 to the 39 times as strong as gravity. Make sure we're running. Thanks for your patience, everybody. So, what are we looking at when we're looking at outside of the atom? We're looking at a certain force which we've been able to measure pretty distinctly, and it's pretty cool. Planck deduced that in accord with blackbody radiation and also in accord with the understanding of what happens when a photon comes in and dislodges or moves an electron from a metallic plate, or in photography, how it dislodges and darkens the silver bromide molecule within that photographic imaging plate which we used in the old days. So what we're registering then is that there's just a real small amount of force which is necessary in order to phase transition the electron from one discrete state to another on the outside of that atom. And this is the amount of energy that it takes. It takes 0.000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 joules. Joules is a ratio of how much work we can get out of amount of force. Code with the energy. So energy is equal to the frequency times Planck's constant. Right? That's what Planck discovered. The energy is equal to the frequency of the light multiplied by this constant. Just a little tiny amount of energy is transferring or forcing the transition phasing of the electrons. So begging myself and the listener to try and comprehend whether or not we've got a correct map, because if we do, universe may be trying to tell us something. It may be trying to tell us, hey, look, on the outside of the atom, force phases like this. And on the inside of the atom, the force that binds the neutron, inside the atoms, phases like this. We've got Planck times 10 to the 34 is equal to 6.625, and that shows up between many different ratios. We just explained on the last chart where it showed up in the alpha and the Penn scales, reminding us that it shows up whenever we add the one frequency vector equilibrium to the two frequency cube, and as these continue to double, the ratios continue to maintain their ratio, so that the vector equilibrium plus the cube's volume is equal to the octahedron's two frequency volume times 6.625. Another thing that we're seeing in this ratioing metric also is where the 2t plus 1 was ratioing the vector equilibrium's 3 frequency volume compared to the cube's 2 frequency volume. 540 divided by 192 is 2.8125. So we've got 2t plus 1 equals 6.625. Remember, 2t plus 1 from the other lectures is the number of orbitals upon the subshells of the electron. I remind us then that the 17 frequency, I'm going to digress for a second. On the next one, where we get to Planck times 10 to the 37, where we have 6625, which showed up in our quantascale measurement, right? Where the quantascale's wave embracement field was equal to 6625 plus 729. We have another compounding at 10 to the 37. I'm reminding us how we got these numbers where the 613 and the 919 are revolving around 3677. In the 17 frequency hexagon, we have 919 closest pack unit radius spheres. It's 918 around 1. In the 17 frequency square, we have 613 closest pack unit radius spheres. These closest pack unit radius spheres then create the ratio of 1, the electron, compared to 1836, the proton, compared to 1838.5, the neutron. Electron, proton, neutron. Sorry if I'm losing my train of thought. What's neat about this is that the hexagon is running on 4 different planes. The cube the square is running on 6 different planes. Now these spheres that exist in the 17 frequency hexagon are then transforming themselves into octahedron and tetrahedron's vectors at these much higher frequency counts. So once again at the 3676 frequency, right, compared to the 17 frequency for where these numbers first showed up, that 3676 frequency tetrahedron has exactly this many vectors times this many vectors. Remember how we transform those all over on the other scale. So here we have h times 10 to the 40 is equal to 6625000, right? And then in that quanta scale's 0-point measurement, we're adding 1 divided by alpha times 10 to the third, and we're subtracting the proton's rest mass. So where are we going with this? Well, physicists are telling us that the strong force is approximately 10 to the 39 times gravitational force. Arthur Young in The Reflexive Universe is pointing out that 10 to the 39 power is equal to the entire size of the universe, which is 10 to the 26 centimeters, minus the size of the proton, which is 10 to the negative 13 centimeters. 10 to the 26 minus a minus, it's like adding it, comes to 10 to the 29. 10 to the 39. So he's pointing out some interesting facts, and I'm just showing now then that if this is a correct representation of map, and the universe wants us to have a model of its nucleus, maybe this really is ratioing approximately and showing us approximately why we have 10 to the 40 power times that original outside force inside the nucleus of the atom, binding it as a vector total with these other nuclear numbers in order to create structure. Not a building block, but structure by self-stabilizing intertriangulated patterns into larger and larger polyhedral forms and continuums of polyhedrons. So it's interesting how in the 17 frequency this gets started, turns into this up at higher frequencies, and I'm just going to point out once again then that 6.65 times 10 to the 34 shows up in the 17 frequency times 2, or 34 frequency vector equilibrium. The 34 frequency vector equilibrium has 800,088 total number of vectors, and those vectors can be blown up, for instance, in a Large Hadron Collider in order to equal 9,384 times 6.65 times 2 plus 9,384,000 divided by 92 times 6.625. Once again, the 3676 frequency tetrahedron's total number of vectors, which is a total number of forces which are stabilizing themselves in this size tetrahedron, and that's equaling the mass of the neutron times 2 to the second power minus the mass of the electron divided by 2 multiplied by the mass of the neutron times 4. I'm going to be giving one more lecture, I believe I will be anyways, on gravity. I'm going to be talking about curvature, simple curvature, compound complex, or complexedly compounded curvature. I'm going to be talking about tensile integrity and tensegrity structure, and other aspects of universal affairs which may not be calculated into the current paradigm. Remember, words cause conditioned associations and mechanical reactions keep our mind locked into specific realities. We have to change the words we use in order to change the mental function and the reality that our mind has. Could this be a reality which is more in tune with structuring universal affairs at subnuclear levels? I believe it may be. I think it's a beautiful thing that all of these numbers are showing up for us. Once again, then I'm just going to give one more lecture, including leveraging. That's the other thing I was going to talk about. I'm going to talk about gravity again, and I mean about the strong force relating to gravity, and that concludes it. I'll give one more lecture after that, which is going to be really fun, because I'm going to do my best to explain how, what I think we all know, the universe is alive. What we might not really know is that the universe is conscious, and photons are conscious, and molecules are conscious at some level. We'll discuss that more in my next, or one of the next videos. Thanks again for joining me, you guys. Really appreciate your time.